This is Nuclear Physics with Funfair. Today we will talk about radiation. There are three kinds of radiation which takes upon when an isotope, let's say uranium-238 for example, needs to change in order to stabilize and not explode. First of all, there is alpha radiation. Alpha radiation, as we can see in the graph over here, let's say, as the example as I stated before, uranium-238 loses a helium, something that looks like a helium nucleus, which is just 2 protons and 2 neutrons, making it polonium-234. This helium nucleus can also be called an alpha particle. And alpha particles are really weak. They can be stopped by a thin sheet of paper, kind of like this one, or by simply just being in the air for too long. Now we will see beta radiation. In beta radiation, we can see that in this case carbon-14 becomes nitrogen-14 by having one of the neutrons lose a small portion of itself about the size of an electron. But for us, let's gonna say that it is an electron, and making it one step further in the periodic table. As you can see, the masses are the same in both sides of the equation, 14 and 14, except that the carbon has gone one step further on the periodic table, making it nitrogen. And now it's let out the electron, or the beta particle. Beta particles are a little bit stronger than the alpha particles. They can cause a little bit more damage, and they can also go through the sheet of paper, and it can be stopped by aluminum foil. Finally, we will have, as well as gamma radiation. Gamma radiation doesn't really have a specific formula for it, as the only thing it does is free energy from the isotope. It can occur with any isotope that has been charged up with too much energy, and it will eventually release it all, which is considered a gamma ray, or a gamma particle. But we refer to it as a gamma ray because it's not really matter. Gamma rays are really, really strong. They've caused a lot of damage, and, well, gave Hulk the superpowers. And the gamma rays can be stopped only by about 6 inches of lead. Now we will see another side about the nuclear physics, which is nuclear fission. Nuclear fission occurs when a neutron will hit an isotope, let's say uranium-235, and it'll cause the isotope to divide into two. In this case, it divided into krypton-91 and barium-142. This fission has caused a lot of energy. It's really raw and it's hard to control. Also, we can see that it's freed also 3 neutrons. These 3 neutrons, if there are around more and more isotopes of uranium, they can cause a chain reaction, as I will show you right here. See, as our original sheet of uranium-235 has divided itself and has hit this uranium-235, made it split into more krypton and barium, causing a lot more energy, and this neutron has hit this other uranium isotope, causing the same effect, and same with this one. And then all of these neutrons will hit another uranium, and another uranium, and so on and so forth. Nuclear fission is the base of the atom bomb, one of the most destructive forms of weapons there are. It is really deadly, and it's caused a lot of damage. Anyhow, now the last part of it. Nuclear fusion! Nuclear fusion has been one of the greatest projects that many scientists have tried to gone through, which is the fusion of two atoms. For example, I'm going to talk about the ones that occur on the sun most of the time, which is of hydrogen, or deuterium, which is heavy hydrogen, which causes a helium nucleus and at the same time massive amounts of energy. This occurs in the sun all of the time, and it's what causes great amounts of heat, which has given life to this planet. Fusion is still out of our reach for now, but who knows, we might find it someday. This was my documentary on nuclear physics. I hope you enjoyed. Thank you very much.